This is part 4 of the spring final exam review. This first section here is adding and subtracting rationals. These are pretty difficult, so I want to do these slowly. Any rational that we're adding or subtracting, the most important part is the common denominator. If these denominators don't match up, we can't move forward. So the first thing we're going to do anytime we see rationals is factor the denominators. Always factor the denominators. This denominator right here is a trinomial, so we're going to add and multiply. The numbers that add to -10 and multiply to +9 are -1 and -9. So that tells me that we can replace this with m-1, m-9. And I'll actually write that a little bit bigger for you. So we get m squared minus 7m minus 18 over m-1 and m-9 plus 6 over m-1. Now, we want to think of these two as jealous neighbors. They want what's in each other's denominators. Now, they both have the m-1, so they're not very jealous of that. This second guy, however, is jealous of this m-9. He wants the m-9. So here's how we get that to him. We're going to take it, and we're going to multiply by m-9 on the bottom to give it to him. But if I multiply on bottom, I have to multiply on top. And here's how this is going to work. We are going to, on top, distribute. So we get 6m minus 54. On the bottom, we could just jam our factors together. That means I can now rewrite this guy after we went through this process. We can rewrite him as 6m minus 54 over m-1, m-9. Now notice these two have the same exact denominators. Now we can add and subtract them. When we add and subtract with rationals, when the denominator is the same, we're not going to change it. On top, we're going to take the top pieces and combine like terms. So like terms, m squared, -7m and 6m are like terms, so -1m, or just -m. -18 minus 4 is I'm sorry, that should have been a 54. -18 minus 54 is -72. And so we've done our adding. The last thing we have to do is factor anything else we can to see if we can reduce. We see that this top piece here is a trinomial, so we want to add to -1 and multiply to -72. We're going to do that by factoring it down to m-9 and m-8. And on the bottom we still have m-1, m-9. And we should know from part 3 of the review, go back and review it if you need, when we have an exact match, we can reduce it. So our final answer is m-8 over m-1. And that's how you do number 1. Fairly long and a lot of steps, so make sure you go through this slowly. You may need to rewatch this a couple times. I'll give you a second to pause this video in case you need to finish it, because I do need to erase this in order to do number 2. Okay, number 2. Again, start by factoring those denominators. 2r plus 1 doesn't factor. 4r squared minus 1, that's a difference of perfect squares. They're both perfect squares and it has a minus sign. So when we factor it, we'll take the square roots, so we get 2r and 1, put a plus sign between them, and a minus sign. Now, just like before, we're looking for those jealous neighbors. It's not so much jealous of the 2r plus 1 because they both have it. What this first guy is jealous of is the 2r minus 1. So let's get him that 2r minus 1. In order to do that, we're going to multiply on top and bottom that 2r minus 1. On top, we will distribute. We get 2r squared minus r. On bottom, we can just jam it together. That means now we can replace this first guy with this guy. So I get 2r squared minus r. 2r plus 1 times 2r minus 1. See how that kind of evolves after we manipulate the fraction? Then again, same bottom, so we'll keep it as is. Notice it doesn't matter what order these two are written in, as long as both of them are there, it's the same thing. On top, again, we'll combine like terms. We get 2r squared minus, plus 11r minus 6. And so on top, we have another trinomial, but in this case we'll use the rainbow method because r squared is not alone. I'm going to jump ahead. If you need help on how to do the rainbow method, that is, actually I'll just do it out for you. So I get 2r squared plus 11r minus 6. Rainbow method, we're going to rainbow the 2 over. We get r squared plus 11r minus 12. That factors to r plus 12, r minus 1. Because we rainbow the 2 over, we need to divide by 2. We get r plus 6. That doesn't divide, so the 2 comes up in front of the r, 2r minus 1. What that ultimately means is we can replace this top guy with the factored form. So we'll get, instead of that, we'll put r plus 6, 2r minus 1. And then what reduces? That 2r minus 1 is an exact match. So our final answer is r plus 6 over 2r minus 1. You see how much room this takes? At times I erased and rewrote. You may want to rewrite all the steps on a separate sheet of paper so that you can see all the work done out. Make sure you know what you're doing. Again, I'll give you a second to pause this. Now, number 3. On bottom we have 8a and 24. When we think about this, 8a and 24, it's not attached, neither of these are attached by plus or minus. It's not like we have plus x over here. They're all just one thing, so we need to turn one of them, or we need to turn them both into the same thing. How can I turn 8 into 24? I can multiply it by 3. So we'll do a plus 4 over 8a times 3 over 3. That'll give me, again, on top we distribute, so we get 3a plus 12 over 24a. And how can I turn 5 over 24 into 24a on the bottom? Times a up on top and bottom. So when we rewrite it, we can rewrite it as 3a plus 12 over 24a plus 5a over 24a. Now that the denominators are the same, we can combine our like terms. Or we could keep our denominator and combine our like terms on top. We get 8a plus 12. Then our last step is to factor what we can and reduce. 8a plus 12, there's a GCF of 4, so we'll factor that out. That 4 over 24 reduces to 1 over 6. Our final answer is 2a plus 3 over 6a. Again, I'll give you a second to pause it. Now, number 4, we only have one factor on each there. Nothing needs to be factored, but they don't match. So when they don't match, they're both jealous of each other. This first one's jealous of the h plus 5. This one's jealous of the h plus 2. So in order to fix that, we'll multiply him by h plus 5 over h plus 5. On top we distribute, we get 2h plus 10. On bottom, jam it together. The second one we have multiply by h plus 2 on top and bottom. So now we can rewrite it as now, before we combine like terms, when we see minus, very similar to on part, it was either 2 or 3. It was part 1. When we subtracted, part 1 of the final review, go back to subtracting polynomials, it was numbers 6 and 10, I believe, 7 and 9. Number 7 and 9 on the final review. When we're subtracting polynomials, we need to distribute the negatives. That now becomes plus -5 minus 10. And that's going to help make a difference when we combine like terms. We're going to get, keep your common denominator, 2h minus 5h is -3h. 10 and -10 is 0. So therefore, nothing else factors, nothing else reduces. That's your final answer. Adding and subtracting rationals is one of the hardest things that is going to be on this final. Make sure you study these and know what's going on. So jumping down to number 5 and 6, now we are not adding or subtracting rationals, we are solving rationals. Step 1 is to find the LCD, the lowest common denominator. Here's how we do this. Start with your first guy. His denominator is a. Okay, cool. We'll put an a. Then, just like adding and subtracting with the jealous neighbors, we see a plus 5. Do we see an a plus 5 here? We do not. So we need to multiply that a plus 5 in. Remember, when there's a plus or minus sign, it comes as one package deal. We can't just put the plus 5 in for the common denominator. We need to put the entire a plus 5. This is all one package deal. Next thing we need to do is find our excluded values. We do that by taking our lowest common denominator. Anything with a variable, anything with an x, anything with an a in this case, set it equal to 0. And solve it. What that means is a cannot equal 0 or 5. If we come up with 0 or 5, that's going to be a no solution. So what we're going to do is we are going to, let me write these a little bit bigger. We're going to multiply the tops of both of these rationals by the lowest common denominator. So times a plus 5, times a plus 5. Now we're going to reduce what we can. See that a will reduce that a. I'm left with a minus 8 times a plus 5. On this side, the a plus 5s will cancel out. I'm left with 3a. And so when we're multiplying polynomials, remember we use double distribution or the box method. We'll get a squared plus 5a, distribute the negative 8, minus 8a minus 40 equals 3a. We can combine, that should be 5a. We can combine our like terms. A squared minus 3a minus 40 equals 3a. And now what we're going to do at this point, if we just have x, we'll solve for x. If we just have a, we'll solve for a. In this case, we have a squared. When we have a squared, the rules change. In this case, we are going to have to move everything over to one side. So we'll move the 3a over. And we will get a squared minus 6a minus 40 equals 0. Now that we have a trinomial right here, we will solve it by factoring. That is going to factor down to, the two numbers that add and multiply, a minus 10, a plus 4 equals 0. Set them both equal 0, a minus 10 equals 0, a plus 4 equals 0. We'll get a equals 10, and a equals negative 4. We need to check these against our excluded values. In this case, we cannot get the answer of 0 or 5. Neither of our answers were 0 or 5, so we could keep them both. So our answers for this one are 10 and negative 4. Let's move to number 6. So just because there are 3 rationals in the problem doesn't mean the process changes. Let me erase this to get some room. I'll give you a second to pause. So we still need our LCD. Start by the first one, we have 2n. Now we have n squared. So we're multiplying, we already have 1n. We need to multiply in another n. Everyone sees how that works. This is 2n, this is nn, this is 2nn. This first one was 2n, so we put 2n in. Then I had n times n, so I multiplied in another n. It's not a package deal if it's not attached to a plus or minus sign, so you could multiply pieces in. And then the third one, we have 2n squared, and that's already there. If it's already there, we don't need it again. Now for excluded values, we'll set it equal to 0 since there's only one factor here. Divided by 2. Square root. N equals 0. N cannot equal 0. Now we need to multiply our top pieces by the LCD. We get times 2n squared times 2n squared times 2n squared. This first one, the 2 will cancel out, and one of the n's will cancel out, so we're left with 3n. This next one, the n squareds will cancel out, I'm left with plus 2. This one, the whole thing will cancel out, so I'm left with n minus 2. Now if I did these solving expressions right, every piece of every denominator should cancel out. If it doesn't cancel out, your LCD was wrong. And from here, because there's no n squareds, we're just going to solve for n. So move your n's to one side. And then we're going to do just solve for x like a regular two-step equation. We get n equals negative 2. The only answer we could possibly not get is 0. Because our answer is different than 0, we could keep it. That's our answer. N equals negative 2. So that's it for rationals. At this point, we're going to switch gears into exponentials. We're working with different types of exponents. So number 7, rewrite the expression in radical form. Here's how we do that. Whatever our base is, anytime you see a fraction in the exponent, see how we see 1 over 4? Anytime we see a fraction in the exponent, we automatically think radical. The base is our base. Now when it comes to what goes where, the top number is always the exponent. So that's really 10 to the first power. Now we should know by now that we don't need to write to the first power because anything to the first power is itself. The bottom is the root number. Remember, the root number comes out in front of that top corner. And so there's our final answer. Number 8, again, fraction means radical. We get x, the top number is the exponent. The bottom number is the root. So that's the answer there. Number 9 gets a little bit trickier because now there are 3 different pieces here. We have 4ab squared and then 1/2 outside of that. So before we do anything, we need to do, we'll put everything under the radical. Notice that 1 is the exponent for the whole thing. The top piece, we don't need to put that because 1 is already there. And 1/2 means little 2 there. Again, we don't need to put it. It's assumed it's a little 2. Now let's see what we could take the square root of. Can we take the square root of 4? Yeah, we can. It'll come outside the radical as a 2. Can we take the square root of a? No, we can't. Can we take the square root of b squared? Yes, we can. The square root and the square cancel each other out. So when they cancel each other out, it comes outside of the radical. Another way of doing this is we could distribute the 1/2. And so that'll leave me with 4 to the 1/2, a to the 1/2, and b, when we multiply that 1/2 times 2, we get 2 over 2. 4 to the 1/2 power, you could punch that in the calculator. You'll see it's 2. A to the 1/2 power, we need to put under the radical. Remember, 1/2 power is the same thing as square root. B to the 2 over 2 is the same thing as saying b to the first. Number 10 is also a little bit tricky because the 9g is not in parentheses. We know from order of operations that the exponent comes before the multiplication. So first thing I'm going to do is worry about the exponent. G to the 1/4 power is 4th root of g. Remember, this is always the outside number. That's the root number. That 9 is not affected because it's not in parentheses. We haven't done the multiplying yet. Therefore, that 9 stays outside of the radical. It would be different if this 9g were in parentheses. Then the whole thing would be under the radical. But that's not true in this particular case. That's not what we had. 11 through 13, we are going the opposite direction. Now I'm giving you something in a radical, and I want you to rewrite it as an exponential. So we'll take our base. The exponent out here, if there is no exponent, we know is 1. That exponent goes on top. The root number goes on bottom. So our answer there is 15 to the 1/3. Here we have 10x all under the radical. Make sure you put in parentheses if it's all under the radical together. Remember, our exponent is the top number. Root number is the bottom number. There's our final answer. Same thing with number 3. All under the radical. If it's all under the radical, we put it in parentheses. The exponent out front, or the exponent in back, if there is none, is 1. The root number is 3. There's our final answer. Number 14, 15, and 16. These are a little bit tricky. So here's how we do that. We have 4th root of 16, x to the 5th, y to the 9th. If I see a bunch of terms under the radical, the first thing I'm going to do is separate them. Now, fourth root of 16, very simple. You can punch that in the calculator. We'll see it's 2. Fourth root of x to the fifth. Let's think about this in another way. Let's think about this as a fraction. Remember, this is our top number. This is our bottom number. So we could think of this as x to the 5 over 4. What's 5 over 4? If we were to do an old school third grade way, we would get, how many times does 4 go into 5? We would get 1 with the remainder of 1. What that means, we're going to take this guy, that's going to be the exponent when we drop the letter down. Then we're going to put a radical, and this is going to be the exponent on the inside guy. Again, we know we don't need the 1 as an exponent, but that way we know what the exponent is. Ignore that 5x to the fourth up there. That is not part of the answer. So that's how we did that. We wrote it as a fraction. We saw what we always want to do is exponent divided by root number. So when we put that together like we did in third grade, we get our answer and our remainder. The answer is the exponent of this guy outside the radical. The remainder is the exponent on this guy inside the radical. So when I see y to the 9 over 4, we're going to do, how many times does 4 go into 9? It goes twice with the remainder of 1. Because that goes twice, we're going to put y squared out here. Inside we'll get y to the first. Again, we don't need that first power because we know what the first power is. And so this is your final answer. Number 15, same idea. First thing we're going to do is separate it. Now we know from previous problems that if there's no root number out here, it's 2. That means square root. When we take the square root of 54, that's not possible. But we can divide away a perfect square. So what perfect square can divide from 54? Perfect square we can divide away is 9. Now, what times 9 is 54? Is 6. What's a square root of 9? 3 rad 6. So we're left with 3 rad 6. So when we do our answer, we get 3 square root of 6. Now we'll take a look at this next guy, x to the 5th. We know the root numbers here is 2, so we'll do, how many times does 2 go into 5? It's 2 with the remainder of 1. So that means we'll get, that 2 tells us x squared, remainder of x. Y to the 8th, again, square root, so how many times does 2 go into 8? 4 with no remainder. If there's no remainder, we don't put anything under the radical. No remainder, nothing under the radical. We'll just get y to the 4th. And here we have z to the 1st, right? If there's no exponent, so we get 2 into 1. No way to make a whole number. The only way to do it would be a decimal. If the only way to do it is a decimal, it stays under the radical. And so this is our final answer. Give you a second to look at that before I erase it. Number 16 is same idea. We're going to split it up. We get 5th root of 243, 5th root of x to the 10th, and 5th root of y to the 25th. 5th root of 243, plug that in the calculator, it's 3. 5th root of x to the 10th, we'll do 5 into 10. We'll get 2, no remainder, so that's x squared. 5 into 25, we get 5, no remainder, so we get y to the 5th. That's your answer. If there's no remainders, you don't need a radical. Number 17 is a little bit different. This is the properties of exponents. Notice I have 2 bases here. I have a b and an a, and I have an exponent outside of the radical. Here's how we handle that. We take that exponent, we distribute it to both of our bases. So we get b squared. That a already has the -5, so when we distribute the 2, we will multiply those two exponents together. So we get a to the -10th. And then what does negative exponent mean? Remember, we can't leave a negative exponent. That means drop that piece to the bottom of a fraction. And when you drop it, the negative goes away. That's your final answer. Number 18 looks like a trick question, but there's no x's or anything, so we could just plug it in the calculator. We get -4. Number 19, again, 2 pieces under the radical with a root number outside. We're trying to simplify it, so we will separate it. This first one, we get 4 into 8 goes twice, so I get x squared. 4 into 12 goes 3 times. We get y to the 3rd. That's your final answer. Number 20 is very similar to 17. I have a bunch of bases inside and an exponent outside. Remember, when that happens, we distribute the exponent. So I get 3 to the -2, x to the, remember, something's there, we multiply it. So -2 times -2 is +4. I get y to the -8th. Remember, negative exponent means drop to the bottom of a fraction. So I get x to the 4th over 3 squared y to the 8th. And that 3 squared right there, we know by now that 3 squared is 9. So our final is x to the 4th over 9y to the 8th. That's your final answer. When we divide, number 21, when we divide and we see the same base letter on top and bottom, what we do is we subtract the exponents, and it's always top minus bottom. So for these u's right here, we're going to do 4 minus 5, we get -1. So that piece of it is going to be, I have 2 on the bottom, u to the -1 on top. And then we have v to the -1 and 2, so we'll do -1 minus 2, we get -3. So u v to the -3. Remember, those negative exponents mean bottom of a fraction, so when we rewrite it, we'll get 2u to the 1st, v to the 3rd on bottom. The negative drops when the negative goes away when it drops. Notice we got rid of everything on the top of the fraction. If we get rid of everything on the top of the fraction, just put a 1. There's your final answer. Number 22, same idea as 17 and 20. We have, except there's only one base inside. If there's a base inside with an exponent, we're still going to distribute that exponent that's outside the parentheses, but there's only one place to distribute it to. The -1/2 was already there, so -1/2 times 1/4 is -1/8. And again, that negative means drop to the bottom of the fraction. And that's your answer to that one. Moving to number 23, we're multiplying, and notice we have the same base on all of them. If we have the same base on all of them and we're multiplying, what we're going to do is we're going to take the exponents and add them. Your handy dandy calculator will do this complicated fraction addition for you. You'll find out this all equals 2. So our answer is x to the 2nd power, or x squared. That's all you have to do when you're multiplying and all the bases are the same. Number 24, just like a bunch of them on the last page, you see a base with an exponent and another exponent outside the parentheses. We'll distribute it. There's only one place to distribute it to. We'll get a to the 3 over 12, which reduces to a to the 1 over 4. Remember, when we distribute, if there's an exponent already there, we multiply them together. Number 25 is very similar to number 21, where when we're dividing, the base is the same. In this case, they're both r's. We take the exponents and we subtract them. And again, it's top minus bottom. Our answer is r to the 8th. Make sure you know these properties. They will be very important come time to do the final. You will need to know how to do all of them. Sometimes you'll need to know several of them in the same problem. 26, 27, 28 is solving. Most of us were actually pretty good at this, so we'll do it real quick. When we solve, the first step is get the radical piece by itself. We can't move forward until that happens. So we're going to solve it like a two-step equation until we get to that point. So we'll do plus 3. Then we'll divide the 2 away. The next thing we're going to do, now that it's by itself, notice this is a square root. If it's a square root, we are going to square both sides. And then solve for x. Now this is only part of the problem. We've solved it, but if it's a square root, we must check it because it's possible we got a solution that doesn't exist. So in order to do that, we're going to take what we got, plug it into x. So we'll get and when we work this out, we'll get 2 times the square root of 36 minus 3 equals 9, which means 2 times 6 minus 3 equals 9, which means 12 minus 3 equals 9, and 9 equals 9. So that's a good answer. We could keep it. And that's how you solve a square root. Number 27, that 1/3 power we should know means cube root. If we're not comfortable seeing that, we can rewrite this as with a cube root. Same first step, get the radical, or if you're working with it in parentheses, get the parentheses by itself. Then we're going to, because it's a cube root, we're going to cube both sides. Again, that would work the same way here if you cube both sides. If you did not switch it to be a radical. And then simply solve for x. Now on a cube root, you do not have to check it. You won't get points off if you do not check a cube root. Square root you must check, cube root you don't have to. I would recommend still checking it because this will tell, by checking it and plugging it in, if you do all that and you plug it in the calculator and make sure it comes out right, that'll just tell you simply if you got the right answer or not, and that's always good to have. Number 28. This one gets a little bit harder. Again, step 1, get the radical by itself. Notice it's separated by that plus sign. So when it's separated by a plus or minus sign, we're going to add or subtract whatever we need to do in order to get the radical by itself. Now to get rid of the radical, just like number 26, we're going to square both sides. Now m minus 4 squared is not, definitely not, m squared minus 16, and just squaring both of them. We need to, for m minus 4 squared, we need to m minus 4 times m minus 4 and double distribute. We'll get m squared minus 4m minus 4m plus 16, or m squared minus 8m plus 16 equals. Make sure you don't make a mistake just because you're moving too fast and didn't double distribute. Just like any other problem we've done this year, if we see x squared at this point, the rules change. Instead of just simply solving for x, we're going to have to move everything over to that one side. We get 0 equals m squared minus 5m plus 6. And what we get is a trinomial, m squared minus 5m plus 6. Add and multiply. It's going to be m minus 2, m minus 3. Those add up to negative 5, multiply to 6. To solve, we'll set them both equal to 0. We'll get m equals 2 and m equals 3. Again, we are not done. We have to check this. I'll erase these two problems to give us room to check. So you plug these two into the original equation. So I'll do 4 plus negative 3 times 2 plus 10 equals 2. So 4 plus negative 6 plus 10 equals 2. 4 plus radical 4 equals 2. 4 plus square root of 4 is 2 equals 2. And I get 6 equals 2. Not true, is it? So that means 2 is not a solution. So we got to reject it. Then we'll do the same thing with 3. We get 4 plus negative 3 times 3 plus 10 equals 3. So 4 plus negative 9 plus 10 equals 3. 4 plus radical 1 equals 3. 4 plus square root of 1 is 1. 5 equals 3. That's not true either. So the 3 doesn't work. The answer is no solution. So that is it for part 4 of the final exam review. Stay tuned for part 5 coming soon. Make sure to rewatch these videos several times. I know they're long, but they will help you out a lot as we go through each individual question step by step. So if you need to see these problems done multiple times to help it sink in, absolutely do that. Make sure you're studying hard for this final. We'll see you in class.